Let's take a look at some specific examples. You should be able to take a table of values, a graph, or an equation and determine if it's a proportional relationship. Let's review how that's done. First of all, to test any table of values, we are going to run the ratio test, where we compare the relationship y over x, and that's going to produce our K rate, or our constant of proportionality. If that rate is steady, it is proportional. But if that rate varies, then that relationship is not proportional. So let's take a look at the first table we've been given. We're going to compare 9 over 1, which is a K rate of 9, 18 over 2, which gives us the same steady K value or K rate, 27 over 3, or divided by 3, again gives us a value of 9. And as we continue the ratio test, we see that we get the same K rate each and every time, 9. So this is truly proportional. Yes, it is a proportional relationship. Take a look at table number 2. We do have to compare and check all these ordered pairs. And remember, we're going to put y over x to produce our K rate. Let's get a ratio for each of these. 8 over 1, which of course is 8. 16 over 2, which is 8. 32 over 3. Well, let's divide. 32 divided by 3, if you punch it into your calculator, gives us a rate of 10.6 repeating. So as we compare our rates, we see that it is not a steady, consistent rate. So this is not a proportional relationship. That's how you determine a proportional relationship when given a table of values. Now let's go to the graphs. Take a look at the first graph you've been given. It has to pass two different standards. It has to start at 0, 0, which it does, and it also has to be straight, which it is. So in this case, yes, this is a proportional relationship. Had we been given the blue line, it would have failed the test. The blue line, of course, is straight. However, it doesn't start at the origin. It is anchored here at 0, 20. So it would fail the test. It would not be proportional. And if you look at the second graph, well, it does start at 0, 0, but it's certainly not straight. So no, it is not a proportional relationship. So that's how you determine when you're given a graph. Now let's take a look at the equations we've been given. There's a certain format that we see when you're given a proportional relationship. Y equals K times X. And of course, K is your constant of proportionality. You can also write it this way. K times X equals Y. Now that K rate can take on many different looks. You've been given an example here of Y equals 5 times X. It can look like that. It can look like 1/2 times x equals y. That's a proportional relationship. There can even be a decimal, and it can look like this. 2.7 times x equals y. But basically, when you see a proportional equation, it looks very much like that or like that. The K rate can vary. So all of these equations are proportional. Yes. But let's take a look at the equations given below. If an equation takes on this look or format, it's not proportional. Take a look at the example you've been given. Y equals 4x plus 3. This is linear, meaning it would form a line, but it wouldn't start at 0, 0. It's not because of the plus 3 here. It doesn't qualify as a proportional relationship. Had it been written like this, y equals 4 times x, or 4x equals y, then yes, it would be proportional. But in this case, no, it is not a proportional relationship. Here's a few others that you might see that are not proportional. Maybe something like this. 5 times x minus 1 equals y. Because of this constant, minus 1, it's not proportional. Or even something like this. 2 times x plus 7 equals y. Well, it's linear. It would form a line, but because of the plus 7 constant, it's not proportional. Proportional equations are pretty simple. They tend to look like this. This concludes the video reviewing proportional relationships.